So, welcome to IoT Leaders podcast. With me, your host, Nicole, the CEO of Eseye. And the reason, if you're watching this on YouTube, the reason I've got a picture of planet Earth behind me is I thought that was the most appropriate background for today's subject. So, today's guest is from a very exciting company called Sateliot. Sateliot are one of the new satellite companies that are doing non-terrestrial networks and in low Earth orbit, so LEO as it's known. They actually have satellites up in the sky now. They have paying customers, and we just announced a partnership with them so that our solution, our Infinity platform, our switch, can actually switch between cellular choice and satellite choice, because now with the new standards, the GSMA standards, which you'll hear about in the podcast, we now can actually use the same modem with new firmware in the modem to connect either to cellular or to satellite, and that is a huge breakthrough, which suddenly makes global ubiquitous connectivity, which is what certainly we're all about, even bigger. And you hear a lot here about use cases and technology and differences between the different models that are out there. It's a very informative podcast. The guest is Marco Guadalupi. He is the CTO, Chief Technical Officer of Sateliot. And he's, as you'll hear, he's very knowledgeable, very enthusiastic, and also talking about what's coming next, the different standards, the path to 6G, what 6G is, how satellite solves the problem of IoT connectivity in rural areas, case study of shipping containers with joint customer we already have, obviously out on the oceans. I mean, a whole new exciting world opening up in front of us now. The satellites are actually flying above our heads. So with that, without further ado, let's get started, and let's hear from Marco Guadalupi, the CTO of Sateliot. So Marco, welcome to the IoT Leaders podcast. Nice to meet you.
Nice to meet you. Thank you very much to invite us. Here we are.
Very welcome. So for our listeners and our viewers, because people listen to it on devices, but it also goes out on YouTube, maybe we could just start off by you introducing yourself and indeed the company Sateliot, which is very exciting. So yeah, sort of who you are, what your role is, and a little bit about Sateliot.
Thank you. Thank you very much. My name is Marco Guadalupi. I'm the CTO and co-founder of Sateliot, Chief Technology Officer. Basically, what we did in Sateliot is very easy. At the end, is an innovation in how we want to connect, how we want to offer coverage. But what we are doing is extending the coverage of mobile operator that everybody knows that are in the city, are in also rural area. But when the density of population drop, or we are in the middle of the ocean, or we are in very rural area, what happened that we don't have coverage. So we decided to extend their coverage using satellite in low orbit. We can talk later about that.
Right. Yeah. So let's get some of the key acronyms out of the way for people, because I think, if it's okay, I'd like to go into that point about low orbit now, if we can, because there's lots of different systems out there. There's a lot of companies making a lot of claims. But you're totally, as I understand it, you're totally focused on the phrases LEO versus GEO, so low Earth orbiting
Yes.
satellites, and there are some technical reasons why you think that's really, really
Yes.
important. So maybe you could just go straight into that.
Yes. Until now, we was used to, for example, watching TV connected to an antenna, and sometimes this antenna is connected to a satellite. We have a dish in our houses receiving signal from a satellite that is very far from the Earth. It is positioned in 36,000 kilometers. And this is very, very efficient to offer broadcast services, okay? Because these satellites are positioned in an orbit, it's called orbit, that because the movement of the Earth and the movement of the satellite, it seems to us that is always in the same position. This is called geostationary satellite. We use this satellite during many, many years for TV, for broadcast TV. So we are covering a specific part of the globe, for example, Europe, for example, Africa. Then in the past, people starting offering internet access through this satellite. But what happened? When we want to go further to this approach, because we want to connect object, Internet of Things, like our case, we want to connect small devices to do a lot of use cases. We'll see later. These small devices maybe are on the floor, maybe are beyond a rock, beyond a tree, maybe are on the move. So the position of these devices compared to the satellite is continually changing. What happened with geo? You have to look to the equator where these satellites are positioned. The position of all these satellites is on the equator line that allow us to have this relative position fixed. But when we move, we are in different latitude of the globe, or we are in a container, for example, it's difficult to point our element that we want to connect exactly to the satellite. So envision this situation, we decided to modify the approach and we choose satellite that fly at a different orbit. That is called low orbit. It means a satellite that can fly between a few thousand kilometers until 2,000 kilometers, few hundred kilometers to 2,000 kilometers.
Right.
For example, in our case, we decide to fly our satellite at 500 kilometers. So if we have, for example, a cow connected, it depends where the cow is, there is no visibility to the equator, but the satellite is moving around the Earth because at this altitude, satellite move at 7.5 kilometers per second, very quickly. So maybe the cow is behind a tree, behind a rock, behind a house, but when the satellite moves, in some moment, we can see the object. We can establish this direct vision between the satellite and the element that we want to connect. So thanks to LEO approach, we can increase the probability to establish connection. And then, because we are very near the Earth, we can increase the energy, so the power of the signal that we receive. So that concept of out of coverage can be solved in this way.
And presumably that was a great explanation with the cow. Thank you. Presumably, and we'll get into use cases later on. In fact, we already have a common customer. We'll talk about that later on. But presumably, the fact that you are near the Earth, you talked about the energy, but also the latency is less.
Yes.
Because you've got to take the signal. You've got to go up and down. Or down and up, actually. So
Yes.
you must have a latency advantage as well by
Yes.
this approach.
Yes. Latency is reduced to few milliseconds compared to geosatellite. That to go to geosatellite and coming back, we are around 700 milliseconds. 700 milliseconds. In geo, we can stay around. In LEO, we can stay around 80 milliseconds, 50 milliseconds, 70 milliseconds. We can reduce a lot, and we can reach 20 milliseconds too. It depends of how you approach the network, but yes, you can reduce a lot. It's a matter of milliseconds, few milliseconds, because we are flying at 500, 600 kilometers. So there is a huge difference compared to 30,000 kilometers, and then you have to go and coming back. Okay, so there is a big advantage, for example, to browse internet. So for broadband access, working with satellite that fly at LEO, you reduce a lot, and the perception of the service for the user improve a lot, because the latency is a key element in this connectivity.
Excellent. Now, I've no doubt a lot of people will sort of be in their mind, and they'll say, okay, so what about Starlink? People always say, well, okay, but it sounds like Starlink. But from my perspective, actually, that's also low Earth orbiting. But Starlink, there are some really key differences. I mean, I think that one in particular, Starlink is very much aimed at the consumer side, and that's the big market, rural consumer broadband access. And secondly, and you're very much, we're talking today about IoT. and we'll get back to that. And also Starlink is, there's the whole issue of open versus proprietary standards, isn't there?
Yes, yes. Starlink, well, first of all, Starlink is a broadband service from Leo that improve the latency. That's the key point. Is a broadband. Now they are talking about connecting smartphone, but in any case, always is a proprietary solution. Okay, the approach that Starlink chose was proprietary solution. So their technology is owned by them, is implemented by them. They know the details, and there is a level of captivity for the customer. There is a level of technology lock-in for the customer. Our approach is different. We join an organization called 3GPP that is in charge of telecommunication protocol, mobile telecommunication protocol, with the idea to bring mobile protocol that are open standard to space. In this approach, supported also by the European Space Agency and many other organizations in the world, the architecture, the protocol, the futures involved in this communication are totally open, are totally new by all the players. So an end customer can be a company, can be an enterprise, can be a government, can be a residential user, can be connected to a network in some way that if we want to decide to change the operator because a new service, because a new product, he can do that without changing the terminal device. So the end user is free. You are protecting your investment when you buy your device. And the approach is always based not on my protocol is better, your protocol is worse. No, the differentiation is in the service. So all the ecosystem is focused on offering the best service to the end user and not competing with I have the best protocol. I have this device. No, the device is open. Everybody can build devices that can support this non-terrestrial network communication based on mobile protocols. And then the operator like Sateliot is there to offer this service. I offer this service, this characteristic at that price. So the end user can choose. When you work in other proprietary solutions like Starlink, Iridium, and so on, what we are doing is a lock-in. You buy a device that only works with that company. There is an activity. The customer has to accept any rules that the operator imposes. So is breaking this architecture on terrestrial network is normal. Everybody has a phone. If you want to change the operator because there is a new service, you do that. It's normal approach. Why we don't do that also in space? So that was the approach of Sateliot from the first day.
And I think that is a really key point. So let's go a little bit deeper. You mentioned non-terrestrial networks, or NTN, as it's known, and the industry standard. And I'll come back to the fact that we as Eseye, we're about to, in fact, by the time this podcast goes out, we probably have already had our press announcement out, and I'll come back to what that's about the alliance between the two companies. But the standard, as I understand it, is also linked to 5G, isn't it? It's the
Yes.
5G NTN narrowband IoT protocol,
Yes.
and
Yes.
that standard is really important, as you
Yes.
say. It's not proprietary. It's not a lock-in. So maybe, and I believe you've been involved in committees and etc. on that.
Yes.
So maybe a little bit explanation, because people will they'll be planning for 5G. The operators will be planning for 5G. The customers will be looking at use cases. We know there are major issues to do with narrowband IoT amongst operators, just because the particularly and I've talked about this on previous podcasts. The model for roaming in cellular IoT is that the person you roam onto only gets 20% of the revenue that you get. And the problem is with narrowband, the unit costs are very, very low, which means you're getting 20% of a really low number. So a lot of people are saying, I can't, although technically I can do narrowband, I can't afford to do narrowband from my cell tower infrastructure, my land-based, my terrestrial network, as opposed to my non-terrestrial network. Whereas from your perspective, the idea of having narrowband IoT globally and linked to 5G, and there's a lot of issues to do with the billing, such as the the billing charging evolution standard, which is the new billing standard for 5G. That's all, you're building it all around those open standards, aren't you?
Yes.
Maybe.
Yes. That's true, and that's the beauty to work into 3GPP. First of all, there are many building blocks of the system that already exist. I don't have to think on the concept of how to authenticate the device, because there is a SIM card. That's part of the standard. This is the 5G standard. The 4G standard was on SIM card. I want to extend coverage of mobile operators, so I don't have to think on how to create this interface. No, because there is a roaming interface already well defined. So taking these elements, exactly, we can extend the coverage all around the globe. We can reduce the cost of doing this roaming thanks to the new approach proposed by GSMA. So an operator that has NB-IoT service on the ground can go beyond his region thanks to Sateliot, and avoiding extra cost of the roaming, because we are doing exactly the same interface that we see in terrestrial network with a simple approach, because it's IoT. So the information we have to interchange is very simple. Our core network, that is the standard mobile core network, talk a specific protocol to do that. There is in the middle a transport network for clearing, it's called clearing house for interconnection between mobile operator, and everything is straightforward. There is no extra cost on that. For the mobile operator, is a new revenue stream. I mean, sensor can be connected beyond my network. Okay, welcome. There is an income. Okay, perfect. And they don't have to invest anything. So it's quite good. And the cost of roaming is reduced to almost nothing, because the integration is so simple, based on a few files that you have to move up and down. There is no motivation to block this extension of your network.
And we should say, if it's not obvious, but we should specifically state that it's not theoretical. I mean, you have recently launched satellites. I mean, these satellites are in the air now, and you have customers. Many customers will get onto that, but you have piggybacked on, as I understand it, one of Mr. Musk's rockets, and you have satellites in the air right now.
Yes. August 16, we launched the first orbital plane for a commercial implementation with 4 satellites. It was a very nice mission. We bring the satellite to Germany, to Berlin, where we integrate the satellite inside the box that is called the deployer, and then we move the deployer to California, to the spaceport Vandenberg, and we install these boxes, this deployer, inside a rocket, a Falcon 9, ready to be launched. And finally, August 16, satellite reached the almost 600 kilometers. They was deployed in 2 phases. The first phase, 2 satellites, and then after 1 minute and something, the other third and fourth satellite. So we saw our satellites flying around the Earth in 2 groups, and day by day they start moving. Our satellite have a propulsion system. So the idea is to move this satellite around the globe in one orbit, 90-degree relative position between each of them, and that's configuration of the orbit, and that's configuration of the constellation, crossing North Pole and South Pole every 90 minutes, give us the possibility to offer minimum 1 message per day all around the globe. It's a 5G NB-IoT non-terrestrial network protocol. This is based on release 17 of the standard. On the ground, we have all the ground system to establish the connection to the mobile operator. The mission control center that is controlling, is looking, the housekeeping the satellite every day with different connection. These satellites are connected to the ground through a bunch of ground stations all around the globe that we can use to establish bidirectional connection with the satellite, to housekeep the satellite, to control the flight, to avoid collision. That's one of the important points today. To avoid collision, there are debris in space. The propulsion system allows us to move the satellite if needed. And finally, to offer the service. So we have to move up and down IoT messaging from our customer and mobile that are the mobile operator and the end user that are customer of mobile operator. Okay, so everything is ready to be commercial January 2025, as we always said, and this is a reality. Okay, it's not a protocol on a paper. This is a real implementation of the system with all the elements included.
So just coming back to our cow, if I may, I had an image as you were talking. The way you can connect to that cow wherever he or she is um, uh, is you have the four satellites currently, obviously a lot more in the future, but four satellites currently. They're, as you said, they're 90 degrees to each other, going over the north and the south poles. So it's like I have this image of like almost chopping an orange into four parts. But
Yes.
you've got the rotation of the Earth as well.
Yes.
So the combination of those four slices and the fact that the Earth is rotating gives you touch every bit of territory globally,
Exactly.
Including the ocean.
Exactly.
Back to that in a case study,
Yes.
including the oceans once a day. So right now you can definitely do once a day communication.
Yes. Minimum once a day.
Minimum
Correct.
once a day,
Exactly.
and it's only going to get better as it scales. So what I'd like to do now that we've established that was a very great explanation. Thank you. We talk a little bit about the announcement that, as I say, it could be out already by the time the podcast launches. And as to why we did it, our regular listeners will know that I'm always mentioning the fact that our approach is, we call it the Star Alliance. And we're actually talking the airline analogy, not the space analogy, but the Star Alliance model, where we have 16 operators that we have done different technical interconnects to. But essentially what it means that as our switch, our network switch in our cloud platform, Infinity, can do not only roaming, so we get access to all the roaming agreements for those 16 operators. So we have 700 roaming, well, it's probably 780 or something, roaming agreements. But we also can do what's called federated localization. So we can localize the connection as well as roam. So essentially what that is we're agnostic to the operator. So we have a single eSIM and we don't have a dog in the fight. We're agnostic to the operator, which gives the most choice, the most coverage, and the most assurance that you're not going to get disconnected. But what we're saying now in terms of the next phase of our strategy is we want to move to be agnostic to the RAT, the radio access type. And we can also already do Wi-Fi, for instance, in the device, like we do with vending machines. If you're in a store and the store Wi-Fi is good enough, then use Wi-Fi. But we couldn't cover rural areas, and we couldn't where there's just the economic model doesn't make sense to put the towers up, and we couldn't cover obviously the ocean unless you're very, very close to the port. And there's a huge market for tracking. So from our strategy, what we see is we want to be agnostic to the operator, but we also want to be agnostic to the device. And the thing that's, excuse me, to the RAT within a single device. And the thing that has enabled this for both of us, of course, is this release 17 standard, which I find most people don't know what it is. If I say, well, we can use release 17, it's not a snappily named thing. It's obviously come from telecom.
Yes.
To have a name like that. But essentially, I think the simple guide is that it is essentially means your existing cellular modem in your device, which, as you say, could be a phone, but actually in the IoT world is most often not a phone. It's a device with a cellular modem can now actually connect via our switch, in this case, with the announcement that we're making, to your satellites, which suddenly means that if you have intelligence in the device, you can actually make a choice between whether you want to use satellite or cellular. We have applications that called Smart Connect that runs in the device. You can say if satellite is available and certain other parameters, it could be the latency or whatever, then use it. Or if cellular is available, then pick an operator that has these capabilities.
Yes.
Suddenly you get this opportunity for what we've all been talking about for a while of massive IoT, which it means that you have more and more choices to every device, regardless of where that device is. And so I think the two companies are coming at this together with a common belief based on industry standards and agnostic choice. And
Yes.
that's the way we see the world.
Yes.
So,
Yes. Yes, yes, it's true. And the advantage to have a standard at the end, you want to be agnostic to the RAT, and you want to have a very cost-effective device. Okay, so if you can have a minimum number of radio technology inside the device, you can control the cost of the device. You can reduce the cost of the device. If for every RAT you need to install a different radio chain in your device, your price is increasing.
yeah.
Okay. So nowadays, what we saw until a few years ago was proprietary solution to connect by satellite. Satellite is not something that appeared yesterday. Satellite exists during the last 40 years. Okay. But connectivity was expensive because was proprietary. The point here is to break this barrier to reduce the cost. And to reduce the cost, we need massive adoption. If we join use cases by satellite with the use cases for terrestrial network using the same radio, what we are doing is increasing the market of the device, so reducing the cost of the device. In a seamless way, we move between different RAT, but the same device. So one chain, one protocol, one firmware, one software, and that scale.
And that is the other big subject I wanted to refer to. I think it opens the door for us to talk about case studies. But when I talk to people about satellite, I'm sure it's the same for you. Everybody, they say, "Oh yes, but expensive." And as you say, if you are a proprietary model with a proprietary receiver, proprietary base stations, then yeah, your capital cost is expensive, and you really have to massively scale. But the moment you say, well, you've already got the device, it's software, it's firmware inside your IoT device,
Yes.
then you suddenly have an addressable market of 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 billions and billions of devices without the
It
need
is.
to spend $600 on a dish or something like that.
Exactly.
Let's talk about case studies. And I'm going to go straight into one that's on your website. It's on our website, and keen listeners of this podcast, IoT leaders, may well remember that we did a podcast with a company called T42 out of Israel. And T42 do one of their verticals that they go after. They're a device company, a lot of device expertise, are very smart Israeli engineers. And one of the things that they do is that they are trying to solve the problem of not just tracking containers while they're at sea, but also there's some amazing statistics that there's something like 50 billion of losses from containers every year, which is either down to theft or the physical conditions are not right. It gets too hot in the container because by the time they leave port and by the time they get there, they're basically out of each container is not connected. And so if it takes 12 days to get somewhere and you're carrying food or whatever, it could get hot. Somebody could break open the lock on a container while they're on the ship. They could tamper with it. There could be a container could fall off, a container could get stolen. It could be on another boat, but you know nothing about it until it gets to the other end. And 99% of the containers in the world are not tracked today. So massive opportunity. And they've created this smart lock, which creates an alert if there's a tamper. And they also will allow you to track the containers. And for instance, when you take them off the boat and you put them on the ground at the port, and ports are big because they need space to put hundreds of thousands of containers. It's not just the boats that are big. The ports have to be big because they have to put the containers on the ground. And then the lorries have to come in and they have to find the containers and put them on the lorry. I mean, the logistics, and typically ports are at the hearts of cities, which is massively expensive real estate. So all the opportunity for ROI here is huge. With that sort of background info, you they're one of your customers, aren't you? You're enabling them
Yeah.
to connect while at sea, essentially.
Yes, 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 yes. It's true. Container is a very important. I mean, the logistic as it is, and container in concrete case is a very important market. It's a very big business where logistic in logistic information is everything. Okay, and when you have massive connectivity, I mean, you are connecting all your containers. You can create value on that data. It's not only what is the container. No, no. After that, you can post-process the information of all your container, and you can identify where you have a lack, where you have a problem. So thanks to cloud processing the cloud, thanks to artificial intelligence algorithm that are learning on that data. So you need a lot of data. You can improve your process. You can establish a different management of that container that is for the company is an active asset. So you know today what you can do with the container, but you don't know what you can do tomorrow with all the information that you can bring from the container. Okay, there is a gap there that if you have a sensor at the right price, you have the connectivity at the right price and the right availability, you can exploit all this information to create new revenue stream, to reduce cost, to create new experience for your end user at the end who is buying that container, who is receiving the goods inside the container. This experience, if I buy something and it took 1 month to arrive, is a problem, right? But if I can track, I feel better, right? This happens every day when you buy something in the city and somebody bring to you. So this information create also a new experience for the end user. All these aspects can be explored tomorrow, and T42 is a good example. It's a good example. This sensor need connectivity. You don't care which one, but you need connectivity. NTN, non-terrestrial network, 3GPP, non-terrestrial network, give us this possibility. And if you have GEO, LEO, MEO, any kind of orbit, you can improve the probability to connect this sensor, to connect this tracker, and have all the information you need when you need, anytime, anywhere, any object. That's the approach.
And that's the ocean, which I think I'm right is 2/3 of the world's surface, but I might be wrong. And 99% of containers not connected today, so totally untapped market. But also we talk about rural areas where I said it's
Yes.
not rural.
Yes.
IoT for it's a big issue. I mean, if you're tracking a truck that's driving across the US, large parts of the US have no signal. It's just not economic to have a land-based infrastructure, land-based network, is it?
Exactly. That's true. And not only for tracking objects to track assets. No, there are other use cases where it's not economically feasible to deploy land network. Okay, for example, agriculture. Agriculture is also a very important business. With IoT, for example, you can reduce 30-40% the water consumption
Yeah.
in smart agriculture. Okay, but you need information. What we did a couple of years ago, we opened a link in our webpage to invite company that want to test the technology, and we identify use cases from very different verticals. It's incredible. There are use cases that you cannot believe. What? Yes, because when you have a need, you have an idea and you create a solution. And if you don't have that need, it's difficult. No, but sometimes you saw application. No, it's smart agriculture, but what we are looking is the size of the fruit. So in each tree, we during the day, during the week, during the month, we are sizing the fruit. We are measuring the diameter of the apple, for example. Wow, what? It's not a matter of temperature and soil moisture. No. Okay, there is water, the temperature is right, but what happened to the apple? We want to know what happened to the apple. So there is a sensor that just take the size of the apple. No, it's curious. But in one tree, in every tree, you need to know the size of the apple in every tree. No, it's incredible. So in this web page, people can join the experience, can ask for a proof of concept, can ask to test the service, and we saw application in every vertical, in the middle of the ocean, in the middle of the land, pipeline, for example, for water transport, soil, no, sorry, sun system, no, for example, for energy. So you have infrastructure in the middle of nowhere for energy generation, wind based on sun. So you have a pipe to transport this energy. You have to monitor all these infrastructure. Then you have environmental. Environmental is not a business as it is, but controlling the environmental is important for other company because there are a side effect. If we have a fast flooding, we have to know in advance. But if we see that water container in the mountain are empty and we are during the summer and there is a risk for a fire, we have to be prepared. So why we don't control water tank in the middle of nowhere? What we do today, we took a car we take a car and check what's happening in every mountain.
Yes.
It's
Yeah.
incredible. There's no coverage, of course, there is no coverage there. So all these use cases associated to environmental has an impact on the society with big impact when something happens. So disaster can be, you can be prepared before the disaster and after the disaster occur, what? Again, satellite connectivity give you to stay beyond the land network. After disaster, the first network we lose is power and telecommunication, and communication later. All these three infrastructure are lost. So helicopters, of course, we have helicopters, we have satellite for communication, then we have to find a solution for power. Satellite communication didn't need power on the ground. That's why satellites are good also for disaster recovery. So if we can connect every smartphone, for example, it's fantastic because every people has a smartphone in the pocket, can be connected directly to the satellite. To do that, again, we need the standard solution. To avoid captivity based on one company, two company, three company, we need to open the solution to everybody. So use cases are huge, many use cases. Use cases that you know today, but tomorrow, when you have the infrastructure, you can create new use cases. So there is an iterative process that can exploit when you have infrastructure.
One of the fascinating things about IoT is the use cases, as you say. And again, we did another podcast with a. Funny enough, I'm going to come back to cows again. I just realized, but we did a podcast with a company in the agriculture space. They were actually nominated for a GSMA IoT Project of the Year award at Mobile World Congress last year in Barcelona, and they are trying to track the health of every cow. And just to recap it, the biggest killer of cows is BCE, which is it's basically a cow pneumonia, and it kills about, I think, 12 or 13% of all cows in the year. And the thing about it is, by the time the cow is sick, it's too late, and cows infect other cows. And cows tend to be in rural areas. And but you can actually identify 7 days earlier that a cow is sick because it changes its behavior. It doesn't eat and drink as much, and it tends to, initially it hides in the middle of the herd. And then when it's really sick, it goes to the outside of the herd. It's interesting what animals do. Anyway, so you have to monitor, if you can monitor the cow's position and how often they go to the water trough and the feeding trough, you can actually use analytics to say, well, and they all have a tag on with a number, cow number 342 is exhibiting symptoms. So intercept that cow, even though it looks perfectly healthy to the human eye, because as you said, it's people who go into forests, it's people who go and check on electricity transformers, and they're cowboys. I mean, that's why they're called cowboys. It's people on horses who are paid to look at cows.
Yes.
And so they don't spend all the time rounding them up. They spend most of the time just looking at them. And so you can then do that with Bluetooth and whatever on the water trough. But you have to get the data from the field out. And if you're in rural Montana and there's no cellular phone signal, it just stops dead. So the use cases are phenomenal. And I think it comes back to what we said, is that you ain't seen nothing yet, in effect, on IoT versus massive IoT. The moment you take these barriers down with an open interoperable solution which has choice on the rack type, then we will see a massive explosion in IoT. Which brings me to perhaps the last question. I mean, I guess it's what's next. We've talked about the fact that what's next is no shortage of use cases. We're at the sort of one message a day, so it's not every use case right now. I mean, it's not video, but technology advances all the time. So from your point of view, you know, you've launched satellites, you're now commercial, you've got lots of customers. I see from your website. We've got our partnership where we can now go into satellite multi-rat, and we have hundreds of customers, millions of devices, all of which could use this service. Can you say, to the extent you can say, can you give some glimpse as to what the vision is for Sateliot going forward?
Yeah, thank you. First of all, we have to consider how to grow the infrastructure. So we need more satellite in space for sure to intensify the number of messages per day, the number of messages in specific area, for example. So this is the first orbital plane. It's a minimum workable solution to have something periodic to cover all the globe. We have to add more orbital plane, more satellite per orbital plane. In parallel, we have to push for the technology. So we are working a lot. We are investing a lot in the standard. Release 17 was frozen in 2022, June 2022. This year, June 24, was frozen release 18 that bring a new enhancement to the protocol. Now we are working on release 19 and release 20. All these evolution include, for example, new devices. We are talking about a smartphone that can use the same IoT protocol to send small messaging, okay? SOS messaging, why not? But then we want to send any kind of message. We want to establish phone calls. We want to establish a video call, why not? We want to browse internet. So all these evolution are considered. Sateliot has a very specific focus on IoT. Today is called delay tolerant IoT because we have few messages per day. Tomorrow we want to approach the near real time, so message every few minutes. And finally, we can stay there. We have the technology to reach real time communication with IoT protocol. The difference is in the size of the market. Maybe we stop in delay tolerant until a few minutes, and we leave the rest for critical messaging to other players. It's okay. It's the same sensor, it's the same protocol, it's the same device, and the customer can choose to pay more for real-time messaging and pay less for delay tolerant. It's a matter of sizing the product, sizing the market, and offering the right service to your market. So next step, more satellite and more protocol contribution to have a solid solution to cover as much as use cases as possible.
And I would say totally new use cases that we haven't even thought about yet. I mean, you're sort of describing the transition to, you talk about, I've been saying release 17. I now realize I should now say release 18. And then, as you say, 19, 20, you're sort of describing in a world where instead of 5G being the big thing, now we're into 3D networks that we haven't been able to think about, and 6G, and suddenly it's a completely different world with completely new use cases. And the idea of 3D networks and 6G is most people really struggle just to even wrap their heads around it at the moment.
Yes. 6G will include in their use cases artificial intelligence from scratch. Network need to use artificial intelligence to be operated, for example, to understand the behavior of the customer, the behavior of the end user connected to the network. And it's going to include non-terrestrial network from scratch. In 5G, it was an evolution. Release 16 was 5G, and then we evolve, including non-terrestrial network. In 6G, it is release 21. We are considering satellite, non-terrestrial network, hubs, and satellite in different orbit. Drone has a part of the network. It's another place where we can have a ground station, a base station, and this base station is integrated in the core of the network, contributing to the connectivity. So maybe we have a user that at the same time is connected to different network. And for example, in the night, you can switch off terrestrial infrastructure in some places because you have less traffic, and you can use for global coverage satellite connectivity, for example. So on the street between city, you don't have base station. You just turn off all the base station, and you just cover all these road, all these paths through and non-terrestrial network. You can cover near the border, near the coast, or in the middle of the city. Because on the street during the night there are no cars, there are no people. So if you are outdoor, you can be connected to this wide beam from space. If you are indoor, you can receive signal from few base stations because we just turn off all the others. It's just an example with a big impact on the power consumption of this kind of network. So there are many use cases we can introduce when everything is interconnected. No, I did say always the same example. The public warning system is a way to send an SMS message to all the population in a specific area. This is possible because it exists a standard. When you have the problem, you do 112 in Europe. In every country in Europe, you do 112. Also in North Pole, you do 112, thanks to this global approach based on the standard. So we'll see in 6G more and more new services based on this full integration between all the networks.
And obviously, I think you're Spanish, Marco, and I think that's a very topical subject. Early warning systems for consumers and climate change. So all of this is extremely relevant. I think we should wrap it here. I think this has been one of our more educational podcasts, so thank you. It's a very, very exciting new area. We've been saying for a while we wanted to do a podcast on this, and actually as a company wanting to do an alliance, but we were obviously waiting for the satellites to get up there. And now they are, and we're seeing the use cases, and we've got some customers. I think it's going to be very exciting going forward, and there are going to be many updates, as you say, as the standard evolves, driven by the evolution of the standard. The whole industry will move in this direction. So very exciting. Thank you so much for
Thank you.
being on the podcast, for being our latest partner. We're partners now of each other. And we look forward to exploring very exciting use cases with customers together with Sateliot. And I'm sure people who are listening to this probably even now are tapping away at your website to actually find out a bit more. So thanks again for joining the podcast.
Thank you very much. Thank you to the audience. Bye.
Thanks.